Hello, this is my project and intro to BERT, fine-tuning Google's state-of-the-art natural language processing model to classify movie reviews. So I wanted to begin a little bit of a technical introduction, but I think these ideas are important to understanding why BERT works so well. I imagine most people who know about machine learning have heard of BERT, but probably don't know that they've used it. In fact, 10% of all Google searches use BERT, and it specializes in very long queries because it has a deep contextual understanding of human language. And so what it does really well is word embeddings. The author of the BERT paper, Jacob Devlin, calls the word embeddings the basis of deep learning for NLP. And so before embedding from language models, also known as ELMO, words were given one vector per word, regardless of the context. And so this is obviously a problem if you're trying to understand human language. With a contextual word embedding, you get a different vector for different contexts. So open a bank account versus on the riverbank will produce a separate vectorizer, which is then fed into the model. And so having that context is really key to understanding human language. And the second problem that BERT addressed was this idea that language models were always unidirectional. And it was believed to be a necessary component, because if you create a bidirectional model, then the model would see the word and wouldn't be able to make a prediction. And so the authors came up with this idea of masking 15% of the words at random. And then these randomly masked words would be guessed by the model. And in this way, it would learn context of words. And so in this example, the man went to the store to buy a gallon of milk. The model would guess the word store and gallon and do this hundreds of millions of times in different sentences and gradually learn how to understand the English language. And so that's just a brief introduction to the technical aspects of the model. There's a lot more to it, obviously, but I want to for the rest of this time discuss how I pre-train the model for a specific task. So my data set was the large movie review data set from the Internet Movie Database. My environment was Google Colab. The coding was done in Python, and the BERT model was implemented through TensorFlow Hub. And I also built a comparison model in scikit-learn. So the data set itself has 50,000 highly polar movie reviews with binary sentiment labels, positive or negative. The IMDb website itself obviously goes from 1 to 10, but for the purpose of this data set, the 5, 6, and 7s are left out to produce more differentiation between a positive and negative sentiment. And so my results, my comparison model was a logistic model with a TF-IDF vectorizer, classified with 62% accuracy. And then implementing the BERT-based model, the accuracy jumped to 88%. And so this is the point where I really understood the power of this model to understand human language. And these results can be optimized and improved further, but it does make the point that the BERT model is understanding language at a very high level relative to previous approaches. And so these results were achieved after just 10 minutes of fine tuning on a single GPU in Google Colab. And in my opinion, further gains on this task are close to impossible. One reason is 10% of the views were truncated because the BERT-based model has a 512 token input limit. There are successors to the BERT model, Transformer XL and Big Bird, that address this particular issue, but it's beyond the scope of what I'm doing. And to really understand how this model is understanding human language, I think it's useful to look at the misclassifications. And so here's a positive review that was predicted as negative by the model. I have no idea why everyone hates this movie. To call it a travesty and unacceptable sequel is just unfair. So there's some spelling and grammatical problems that the model has to deal with here. And then there's this idea that a human will pick up on the positive parts in green. I have no idea why. And then the model is focusing on the negative parts in red. Everyone hates it, it's a travesty. And then this person is actually defending the movie. And so the model's attention looks at the sentiment, whereas a human can look at the idea that they're defending the movie. And then we have a similar problem for all the losers who gave it a negative review. It's probably because you had sex once in 2 years or an LTR. And so this person's reviewing other reviewers and not even talking about the movie. And so there's really no way for a language model to pick up on this. So it's picking up on negative sentiment, but a human can understand that this is actually defensiveness. And so machines don't understand this. The opposite side is a negative review predicted as positive. So while the new film is gorgeous to view, the soundtrack is lovely. It is not Jane Austen's Pride and Prejudice. So this is very ambiguous. The language is very positive, which is what the model is picking up on. But a human picks up on the fact that they're saying it's not as good as the book. So it requires some prior knowledge to understand why this is a negative review. And then there's just simply trolling. I only watched 15 minutes of the film. The concept was original, so brilliant, so great, enjoy. And then they give it 3 out of 10. So obviously it's picking up on the positive sentiment, but the human will see that I only watched 15 minutes meant they stopped watching it, probably because they didn't like it. And so also notice that the person says 3 out of 10, but the model doesn't classify on that, which would be data leakage. So it's actually analyzing language sentiment. And machines that pick up on sarcasm. So this is just a limitation that's probably can't really be avoided with language modeling. And so as I was researching this is a quote from Arthur Clarke that sort of occurred to me. Any sufficiently advanced technology is indistinguishable from magic. And there's a lot of complex ideas that come together to understand human language, but it's reached a point where it's very close to, if not at, human level understanding. And that was sort of what I wanted to explore in this project. And I was just, I think, very impressed just by how far the technology has advanced. And it's definitely something I want to learn more about. I just kind of scratched the surface. So. Thanks for listening.